Hello, now I will show you how to apply the transistors on the heatsink. As you can see, I have already applied a few. So you need this type of thing. This is a mica insulator. These are fine mica sheets, which is a quartz-alike mineral, if you will. And this sheet must be greased well with thermoconductive paste, that one over there. And what you must remember when greasing with thermoconductive paste is that you have to apply a very thin, very thin layer of thermoconductive paste. Just like this. So I will apply the layer and film it after it's done. There you have it. This is the thin layer on one side. I have to do the other side. And after that, I will show you how to attach the transistor, well, in my case the MOSFET, on the heatsink. Okay, now I have both sides greased, and as you can see, I have marked the place where the transistor will be mounted, and you have to have a steady hand, which I don't really have right now because I'm tired, and place this greased mica sheet right in the to have its center hole aligned with the hole drilled in the radiator. And then you take the transistor and you also place the transistor on top of the mica sheet with its center hole in the middle. Okay, after that you take a screw. It can be a metric screw, it can be a wood screw, doesn't matter because aluminum is kind of like cheese, it's a soft metal if it's a normal alloy. And then you screw it with a screwdriver. You ensure once again that everything is in place, aligned correctly, and then you can make the final tightening. Wait, like this. Now it's all done, and this is how you mount a transistor or a MOSFET on your heatsink. Thank you. Hello everybody. I have finished assembling the power stage of the variable frequency drive or variable frequency inverter, and now I want to show you as a presentation, a quick presentation, what exactly it is composed of. So I have very poor lighting in here, but I am going to additionally illuminate the power stage, and it is composed of 12 MOSFETs, 6 on each side. It will be a push-pull inverter, so you have two sides. It's like a half H bridge, which are glued to I'm sorry, they're not glued. They are fastened with wood screws into a special kind of radiator I found in a DVD player, and I have dismantled it and used it as a heatsink for my MOSFETs. Between the MOSFETs and the heatsink, there are mica sheets, and the mica sheets and the MOSFETs are assembled together with thermoconductive paste. On the legs of the MOSFETs, I have crimped washer type terminals, and the terminals are tied up to common bus bars. As you can see, there are 3 common bus bars for each side, and all they make up is just like one big transistor. The MOSFETs that I have installed here are 150 volts and 171 amps each. So I have 6 in parallel. You do the math. Okay. On the bottom side of it, where the bronze like wait, let me show you. On the bottom side of the heatsink there is a small fan, and that fan circulates the air through the heatsink so that hot air is evacuated and fresh air, cold air is brought in. Also, I have thought to mount an additional fan to quicken the flux of air, the flow of air through the heatsink, and provide proper cooling to the MOSFETs. Okay, what more I have added is, well, there are 3 computer CPU heatsinks strapped on with cable ties. I have pulled on the cable ties until I was satisfied that they were tight enough. I can say that they almost cried in agony. That's how hard I pulled them. And the heatsinks, the CPU heatsinks, are attached to the main heatsink, this long one on which the MOSFETs are installed, with thermoconductive paste also. And there are three separate heatsinks, and I have placed them in such a manner that every heatsink is mounted on top of 2 transistors. I hope it sees, you can observe it. And I have other plans too for the top heatsinks. I have 3 fans, 3 ventilators, which I will mount on top of them, and I have some temperature, no wait, not temperature sensors. I have some thermocouples, and I will mount a thermocouple on the main heatsink, on this long one, And when the heatsink is hot enough, the thermocouple will close the circuit and will turn on the additional 3 big fans for ventilating these CPU heatsinks. Well, this is my power stage for the inverter, and I will now go on with assembling the rest of the inverter. I will have to take care of the command part, the oscillator circuit and the MOSFET drivers, and also with all the rest of the accessories of the inverter. Thank you. This is my power stage assembled to the bottom part of the box, and this is how it looks like underneath. I have fastened it to the big radiator, well, to the main radiator, with this type of 90 degrees angled sheet metal, and also on the bottom of the inverter's box I did the same. The transformer is fastened in the same manner, and this is how it's going to look like. On the sides here will come the bank of capacitors, which is that one, and the controlling part of the power stage, the oscillator. And then I will have to design a place where to mount the positive bias diodes. I have 2 ultra fast 37 nanoseconds, which is very fast. So I have two diodes at 600 volts and 192 amps and 37 nanoseconds recovery time. Those will be used to capture any back EMF, reverse inductive spike, however you want to call it, which normally would be wasted in this type of inverter. I am not using an H bridge because of the cost of building such a power stage, and because the H bridge, as Doug said, according to his experiments, quenches out any back EMF recovery, whatever. So this is it for now, and I will show you more soon.